Welcome to 10.1. We're talking inequalities. Very basic inequalities, including variables. Before we get there, all the inequalities we'll be graphing or plotting will exist on a number line. So take a moment and review reading and plotting on a number line. Pause the video and come back when you're ready. Welcome back. A was located at -10, B was located at -7, C was located at -3, D was located at 1, and E was located at 9. As far as plotting them, you just simply put a point where the value is. A is 9, so I plot at 9. B is -7, so I plot at -7. C is -1, so I plot at -1. D is 0, so I plot at 0. This should be E. E is at 1.5, so I go between 1 and 2. Let's look real quick at plotting at fractions and decimals. In order to plot fractions, you need to decide which two integers the value is between. So in this case, my integers were 1 and 2. 1.5 was bigger than 1, but less than 2. Then you estimate where to plot. In this case, it was about halfway between 1 and 2. Okay, you want to see whether it's closer to the bigger value or the smaller. Let's try plotting a couple of these together. 3 and 2/3. Well, 3 and 2/3. I picked two integers. It's bigger than 3 but smaller than 4. 2/3 is closer to 4. -3 and 2/3. Now I need to think. Less is more with negatives. So it's between -3 and -4. So we're closer to -4. 7.75. That's between 7 and 8. It's bigger than 7, smaller than 8, but it's closer to 8. If it's more than half, draw it a little closer. Again, this is estimation. It does not have to be perfect. No one's going to pull out a ruler and prove that you're closer or further away from a value. Alright, inequalities. An inequality is a comparison between two values. Okay, we're looking at relative values. Is it bigger? Is it smaller? Is it equal? Is it close to? Is it further away from? These are the basic inequality symbols. Some of these you may have seen before. This one, less than, greater than. Now before, when you did this, we'll talk about it in a moment, this is like the alligator. But certain directions the alligator's mouth is facing mean certain things. This is less than or equal to, see the little line underneath, it means equal to as well. This is greater than or equal to. When you plot, you're going to use different types of circles. If it's just less than or just greater than, it's an open circle. If it is greater than or equal to or less than or equal to, you color in the circle. Because that means that the value is included. Okay, so the value where you plot is included, whereas these empty circles mean that it's not included. All the values are somewhere else, not including that value. We've dealt with the alligator before. You learned about this in probably grade school, middle school. These circles are a little bit off, but we'll deal with it. You always think about the bigger value gets eaten by the alligator. This was probably the common inequality you've dealt with up to this point. But now we're going to be dealing with inequalities that have variables or unknowns. When you have a variable, an inequality acts like a set of directions. The arrow on the number line points to where you can find all the solutions that would make the inequality a true statement. Okay? Think about this in terms of the Wizard of Oz. When we met the Scarecrow, he told us to go one direction, the other direction, or some people go both directions.
Now which way do we go?
Pardon me.
That way is a very nice way.
Who said that? Don't be silly, Toto. Scarecrows don't talk.
It's pleasant down that way, too.
That's funny. Wasn't he pointing the other way?
Of course, people do go both ways.
This is how inequalities work. We're pointing at where the true values are. So, to plot an inequality, we plot the value on the number line using the correct type of circle that's either open or closed. Pick a value on the number line and substitute it in for the variable. If you get a true statement, point at that value, at the value you chose. If you get a false statement, point away from the value you chose. So let's try one of these together. We have x is greater than or equal to -2. First, we ask ourselves, is it going to be an open or closed circle? It's going to be closed because I see the equal sign as well. It's going to be at -2. So I plot a closed circle at -2. Pick a value. If 0 is not this value, if 0 is not in the inequality, I like to use 0. Is 0 greater than or equal to -2? Is that a true statement? Yes. So I'm going to point at the 0, but I'm going to keep that arrow going. That means that any value over here, 14 is greater than -2, 4 is greater than -2, 800 is greater than or equal to -2. X is greater than 11. First, is it open or closed? Because there's no equal sign, it's an open circle at 11. Now I'm going to pick a point. Again, 0 works. Is 0 greater than 11? Is that a true statement? No. So I point away. Point away from the value that I picked. Now up to this point, a lot of people start noticing that the inequality looks like the arrowhead. Do not use that shortcut. The second you start making or using that shortcut, you're going to start making mistakes because you will overgeneralize that rule. I will caution again, do not use that shortcut. 4.3 is greater than or equal to x. Is that open or closed? It's closed because I see the equal sign underneath. So I go to 4.3. 4.3 is between 4 and 5. I estimate that it's closer because 0.3 is less than 0.5. So we closer to the 4. Closed circle between 4 and 5, closer to the 4. Pick a value on the number line. Substitute it in for the variable. I'm going to try 0. Is 4.3 greater than or equal to 0? Yes, in this case, it's true. So I'm going to point at the 0. Now, this is one of those situations where that shortcut does not work. The shortcut only works if the variable's on the left. The problem is not all inequalities are written that way, and switching the inequality around is not always the easiest thing to do, and not always something students remember to do. X is less than -4 and 2/7. Is this open or closed? Well, I don't see an equal sign, so it's an open circle. So I go to -4 and 2/7. That's between -4 and -5. 2/7 is less than half, so it's going to be closer to the -4. So I'm going to go between -4 and -5. Draw an open circle. Plug in a value. Let's try 14. Is 14 less than that? No. If you get a false statement, just like we did in the last problem, you point. Oops, yeah, a true statement in the last one problem, sorry. If you get a false statement, you point away from the 14. So I don't point at 14, I point away from 14. All of these values make it true. -10 is less than -4 and 2/7. On your own, try these problems. Pause the video and come back when you're ready. Welcome back. Let's go through our answers. X is less than 4. That's going to be open at 4. I'm going to test 0. 0 is less than 4. I get a true statement. Point at the 0. X is greater than or equal to negative 12. That's going to be a closed circle at negative 12. I'm going to test negative 14. Is negative 14 greater than negative 12? No. So I point away from the negative 14. Point away from false statements. Point at true statements. Negative 1.3. I see that's going to be closed because I see the equal sign. It's greater than or equal to x. So it's between negative 1 and negative 2. Closer to negative 1. Pick a point. Let's try 10. Is negative 1.3 greater than or equal to 10? No. So I point away from the 10. X is less than 3.5. I don't see less than or equal to, so it's open. 3.5, that's between 3 and 4, exactly halfway between 3 and 4. Plug in a point. I'll try 0 again. Is 0 less than 3.5? I get a true statement, so I point at the 0. The 0 is on the left side, so I point to the left. We just discussed plotting an inequality on a number line. On your own, rate how well we hit the target. If you get a less than a 5, feel like we did not hit it well enough, make sure you come in with questions tomorrow during practice. Thanks for coming by, and I will see you in class.